Okay, so we're going to talk about two different ways you might carry out the garden experiment, an uncontrolled way and a controlled way. Controlled experiments are trying to minimize the impact of lurking variables, unmeasured variables, or measured variables that you can't control the values of. So ordinarily the way you do that is by randomly assigning treatments across all the values of the variables that you don't measure or you can't control, or at least try to make sure the levels of those other variables that might be explanatory are sort of the same across all the individuals as you perform the experiment. So maybe they all vary together. That might be okay too. So they impact all the individuals in the same way over the course of the experiment. That'd be a controlling way to do the experiment. So here's the uncontrolled experiment. I've got those 9 different treatments of water and sun. Try its combination on the whole garden for 2 weeks. Then record the results. So I just set up my watering system, water twice a day. I take the shade cloth off. I let it run for 2 weeks. I look at the plants and say, which ones are healthiest? How is this working out? And then I leave the shade cloth off. I change the watering to maybe once a day. Do that for 2 weeks until eventually I've worked my way through all 9 combinations. And then for each combinations of water and sun, I see the impact on the plants. I've written down what happened. At the end of the day, I say, well, it looks like number 5 was the best. The things that can go wrong here are, well, in each 2-week period, the weather's going to be different. And so over that short period of time, maybe it's great to water twice a day, but maybe over the whole summer that wouldn't work. Maybe it'd be great to have full sun, but maybe over the summer that wouldn't work. And so doing that, all the external variables that are controlling things are also impacting the garden over those 2-week periods. And it might be just the amount of sun and rain that happened in those 2-week periods that made that particular combination of sun and shade and water, so look like it's most effective. So all the external stuff that's happening in that 2-week period might have been responsible for the results and not the explanatory variables that we're changing, and we can't control the weather. So that's the uncontrolled experiment. You're unable to control the other explanatory variables that impact the response, which help the plants. And then, as you try the different combinations of water and sun, as you try the different treatments, you don't know if the treatment is responsible or if the weather is responsible. So I'll put that here. We can't tell if the weather or the levels of the factors impacted the plants more than one plant, the plants health, like that. So when you have two things that vary together, the levels of the factors and also the weather, we call that confounding. So it says explanatory variables vary together. That keeps you from drawing any conclusions. So if you have some explanatory variables that might have a big impact on the response, and you can't control for them, they're just going to happen. And when you change the levels of the factors you're using, if those other things change at the same time, you don't know who made the health better or worse, whether it was the weather or the watering scheme and the sun. And since you can't tell, that's called confounding because both things change at the same time. And then I don't know how I should proceed necessarily because that particular combination of sun and water that made the plants healthiest, that particular 2-week period might have just been a great time for plants to grow as far as the temperature and sun and rain we got ordinarily, and it was nothing to do with my scheme. Too bad. So I can't control for that. So we'll try controlling for it this way. The controlled garden experiment says subject each plot to one of the 9 treatments throughout the summer. Now every plot gets the same weather. Up here, I tried in the garden, the 2-week periods get different weather, but here every plot gets the same weather over the whole summer. And actually that's more realistic because I'm probably not going to change my watering and my shade cloth over my garden over the course of the summer ordinarily. I want to set it up one way, let it run for the summer. What's the best way to do it? So this is the most realistic in terms of how the garden responds. It's realistic because we're using the same treatment over the whole summer. And now we know all treatment groups get the same weather. Which is good in a sense. On the other hand, if it was a wet summer, and that's an unusually wet summer, then I'm going to be thinking I can use more sun and less water than usual. So we still have that problem that what we did, even though we controlled for those variables by making them all the same, except for the treatments that were applied, the choice we make about which treatment we use could have been messed up by just overall how the weather was over the course of the summer, if it was wetter or drier than usual, hotter or cooler, or whatever the situation was. So still, you don't know an answer in one season. You might have to do this over several seasons, and then you have an idea. Subjecting every plot to one of the 9 treatments, and then see what happens at the end of the summer, and do that over several years, and then you know how to grow tomatoes. Possibly. I still don't really know how to do it, so maybe it takes longer than several years. And so now we're going to talk about diagramming experimental designs, or diagrams of experiments. We'll see, I think it's 3 different kinds of experiments. Here is the first one. It's called the completely randomized design. So that says treatments, they're assigned to subjects randomly. So here's that random part. Each of these, so you have your subjects, you have 3 treatments, you pull subjects out one at a time, randomly, randomly. And so the first group, you're going to give treatment 1, you're pulling them out randomly, then the second group, treatment 2, and who's left is treatment 3. So if you had, say, 30 subjects, maybe you take the first 10 and put in the treatment 1, this next 10, and next 10, and the 3 groups. And then you're going to compare the response when you get done, and then you'll see whether treatment 1, 2, or 3 seems to be more effective at whatever response variable you're trying to maximize. This particular experiment, as it's in the notes, is about trying to get people to conserve energy. So the 3 treatments are installing an energy display in the house, so you can watch the energy go all the time, day or night, or receive a monthly chart, so see how much energy you're using every day of the month and what the total was, but you get that at the end of the month. Or sending you energy-saving tips to try to get you to save energy. They do that all the time, so that's the control group. It's the usual way of trying to get people to save energy. And then we'll take our, say, 30 homes, randomly assign treatments. 10 of them get energy displays, 10 of them get monthly charts, and 10 of them get energy-saving tips as a control group. And then we'll look to see, we'll compare this year's bill to last year's bill. Okay. So the question is, why use a control group? Why not just have 2 treatments, energy display in home and a monthly chart? You want to do something. What's the point of the control group? And the problem is, you would like to be able to say that these treatments actually caused an impact. And just because this year's bill was smaller than last year's bill doesn't mean these things did anything. They may have done nothing. It might have been that it was just a kind of weather where you use less energy. Haha. So if you compare this year's bill to last bill over the 3 categories, you look at the people that got the control, so the ones that got the same thing they got last year. Here's your energy saving tips. And you can see how much their energy savings changed, whether it went up or down depending on the weather. And you compare that energy savings to the people that got the monthly chart and the people that got the energy display in the home. And then you'd know by comparison which of the 3 groups use the least energy. And if it's this group, then those things didn't do anything. If it's one of these, then it looks like the treatments cause people to use less energy. Otherwise, if you didn't have a control group, you could say which of those two things seem to work better, but maybe doing nothing actually worked better, and you wouldn't know that. Like, who looks at the monthly chart anyway? And energy display in the home, does that really cause you to do anything? It might not. If you don't know what you're looking at or why you're looking at it, behavior might be the same over all three groups, and then you see the same energy consumption when you compare this bill to last year, that they're all 10% less or 10% more than they were last year, and that the treatments had no impact. So that's why you need a control group, just to see, because it might not be anything they did, it might just be the weather that caused the energy used to change. I know when I look at my air conditioning bill, I know if it's not a very hot summer, I spend a lot less on my air conditioner, and that's nothing I did. I didn't change my thermostat or anything, so you got to be careful you're not attributing the energy-saving treatments to that response when it was just the weather. Okay, we're getting close to the end of these experiments. I'll see you in a minute.